In this episode, we will examine the famous Chinese room argument.
Ah, yes. John Searle, 1980. A real philosophical firecracker.
Definitely. It's one of those thought experiments that really makes you stop and think about, well, thinking itself. What does it mean for a machine, or even us, to truly understand something?
Absolutely. And you have to remember the context, right? This was a time of huge optimism in artificial intelligence. People were genuinely talking about computers thinking like humans any day now.
And Searle kind of pumped the brakes on that.
He did. Especially on this idea that just getting the right program running would be enough for genuine understanding, like understanding language.
Okay, so let's paint the picture. John Searle, the philosopher, imagines himself inside a closed room.
Right. Crucially, he doesn't speak or understand a word of Chinese.
And people outside are slipping questions, written in Chinese characters, under the door.
Inside, Searle has this enormous rulebook, a program basically, but it's all written in English, his native language.
And this rulebook tells him exactly what to do.
Precisely. It says things like, if you see this squiggle followed by that squiggle, then write down this other squiggle. He has stacks of Chinese characters too, like a database.
So he gets a question in Chinese, he looks up the symbols in his English rulebook, follows the instructions to find the corresponding symbols, writes them down, and pushes the answer back out under the door.
And here's the kicker. He gets so good at following the rules, and the rules are so comprehensive, that the answers he pushes out are perfect, indistinguishable from those of a native Chinese speaker.
So to the people outside, it seems like they're having a totally normal, intelligent conversation in Chinese.
Exactly. But Searle, inside the room, he still has zero clue what any of it means. He hasn't learned any Chinese.
He's just manipulating symbols based on their shape, their form, their syntax.
That's the word. He's got the syntax down pat, but he has absolutely no grasp of the semantics, the meaning behind those symbols. He doesn't know if they're asking about the weather or philosophy.
Like knowing the grammar rules, but not the vocabulary or the story.
Perfectly put. And this leads to Searle's direct punchline about computers.
Which is?
If he, Searle, inside the room, doesn't come to understand Chinese just by implementing this program running through these symbol manipulating steps.
Then a digital computer running the exact same program wouldn't understand Chinese either.
Right. Because the computer's doing fundamentally the same thing. He is manipulating symbols according to formal rules. Doesn't matter how fast it does it or how complex the rules are. That process alone, Searle argues, doesn't generate understanding.
But it feels like this goes beyond just language understanding. It hits at something deeper about minds, right?
Oh, absolutely. That's Searle's broader conclusion. He's saying our minds aren't just sophisticated computer programs. Real understanding, real consciousness, he argues, arises from the specific biological processes of our brains.
The wetware, not just the software.
Kind of, yeah. Computers can simulate these processes. They can mimic the outward behavior of understanding. But simulation isn't duplication. A computer simulating digestion doesn't actually digest anything.
Okay, wow. So this little room scenario has some massive implications.
Huge. It cuts right into the philosophy of language, what is meaning, how do words connect to the world, and the philosophy of mind. What is consciousness? What is thought?
And it must have caused ripples in computer science and cognitive science, too.
Big time. It directly challenges the core idea of strong AI, the claim that a properly programmed computer literally is a mind, that it can understand and have other cognitive states. It's no wonder this argument sparked and continues to spark so much debate.
Decades of it. So for you listening, our mission here is to really unpack this argument. We want to get you comfortable with the core ideas, why it's so provocative, and what the main lines of response have been, all without getting lost in the weeds.
Exactly. Let's aim for clarity on this really influential piece of thinking.
So setting the stage a bit more, we mentioned the AI optimism. Alan Turing's test from 1950 was a big part of that, right?
Definitely. The Turing test proposed that if a machine could converse so well that a human couldn't tell if it was a machine or another person, we should consider it intelligent. That really fueled the idea that behavior, the output, was the key thing.
And by the late 70s, some AI researchers were claiming their programs actually understood stories or could engage in dialogue.
There were, which is exactly what prompted Searle to devise the Chinese room as a counterexample.
So just to nail it down again, the English speaker, the room, the Chinese symbols, the English rule book, the program, input questions, output answers, looks like understanding from outside.
But zero understanding inside by the person doing the symbol shuffling.
And the core claim, if the person doesn't understand, the computer running the same program doesn't either.
Because the computer, purely as a computational device, has nothing the person in the room doesn't have in terms of symbol manipulation power.
Now, you mentioned Searle later talked more about consciousness and intentionality. Let's dig into those a bit.
Yes. He refined the argument, especially around 2010, saying implementing a computer program is not in itself sufficient for consciousness or intentionality.
Consciousness, we sort of get subjective awareness. What about intentionality? Sounds intentional.
It's a key philosophical term. Intentionality is the aboutness of our mental states. Your belief that it's raining is about the rain. Your desire for pizza is about pizza.
Okay, so our thoughts point to things, they have content.
Exactly. Searle argues that our minds have original or intrinsic intentionality. It's built in. But computers, and even language symbols themselves, only have derived intentionality. The pattern of pixels pizza on a screen is only about pizza because we interpret it that way. The computer processing the word doesn't intrinsically grasp pizza-ness.
So the computer symbols lack that inherent aboutness.
That's Searle's claim. And this directly clashes with functionalism in the philosophy of mind.
Remind us what functionalism is again.
Functionalism basically says that what makes something a mental state, like a belief or a desire, isn't what it's made of, like neurons, but what it does, its function, its causal role in a system, how it relates inputs, outputs, and other states.
And the computational theory of mind is a type of functionalism?
Yes, a very influential one. It says minds are information processing systems, essentially computers. Mental states are computational states. Searle's argument is a direct assault on this, saying, look, you can have the function, the computation, without the actual mental state of understanding.
It really does sound like a philosophical hand grenade, like you said.
It was. The impact was undeniable. You had figures like Pat Hayes saying cognitive science was basically trying to refute Searle. Steven Pinker noted over 100 articles on it by the mid-90s. It forced everyone to confront these deep issues about computation and meaning.
Before Searle, though, were people thinking along similar lines? Any precursors?
Oh, yes, definitely. The ideas weren't entirely out of the blue. Go way back to Leibniz, the 17th, 18th century philosopher.
Leibniz's mill.
That's the one. He asks you to imagine a machine that supposedly thinks, but scaled up to the size of a mill. You walk inside, what do you see?
Gears, levers, parts pushing each other around.
Exactly, just mechanisms. You wouldn't find anything, Leibniz argued, that could explain perception or thought itself. It's a clear parallel. For Leibniz, mechanical operations don't equal consciousness. For Searle, syntactic operations don't equal understanding.
A giant thinking mill. Very vivid. What else?
Alan Turing himself, actually, in 1948, he discussed a paper machine, basically, a human meticulously following written instructions, say, for playing chess, without necessarily knowing chess themselves.
The human as the computer.
Pretty much. And it raises similar questions.
Yeah.
Does the person understand chess? Does the whole system? What if they memorize the rules? It muddies the water about where the understanding resides, if anywhere.
And Searle's colleague, Hubert Dreyfus.
Dreyfus was a major figure. Starting in the 60s, he was a huge critic of early AI hype. He argued that human intelligence relies heavily on things like intuition, background common sense, skills, things that couldn't easily be formalized into explicit rules for a computer.
He thought the brain wasn't just a digital computer.
Precisely. He emphasized that understanding isn't just about following rules. His critiques definitely paved the way for Searle's more focused argument.
So a growing skepticism about purely rule-based intelligence.
Right. And one more precursor worth mentioning is the Chinese nation or Chinese gem idea.
Where a whole population simulates something complex.
Yeah. An early version involved a stadium translating a sentence. Ned Block's later version had the population of China simulating the neurons of a brain, maybe one feeling pain. These were more focused on consciousness and the qualia, the what it's like aspect, but they also probe whether a system composed of non-understanding parts can collectively achieve understanding or mental states.
It's fascinating how these threads came together. Okay, so Searle throws down this gauntlet. How did people push back? What were the main replies?
They came thick and fast. You can roughly group them into 3 lines of attack.
Okay.
1, sure, the guy in the room doesn't understand, but something else does. 2, maybe the original setup is too simple, but a different kind of computer system could understand. And 3, maybe our initial reaction is wrong. Maybe the guy does understand in some sense, or the whole thought experiment is misleading.
Let's take that first one. The system's reply seems like the most obvious pushback.
It was, and it came immediately. The argument is simple. Don't focus on the man inside. He's just the CPU, the processor. The whole system, the man, the rule book, the database of symbols, the scratch paper,
Yeah.
that's what understands Chinese. Understanding is a property of the system, not just one component.
Makes intuitive sense in a way, but Searle had a counter for that.
He did, a famous one. He said, okay, imagine I memorize everything. I internalize the rules, the database, all of it. I do the calculations in my head. Now I step outside the room.
So he is now the entire system.
Exactly. He is the system. But, he argues, he still doesn't understand Chinese. He's just running the program internally. He still wouldn't know what hamburger means if it came up in the conversation.
Yeah.
Internalizing the syntax doesn't magically create the semantics for him.
That internalization argument seems pretty powerful. Did people just accept that?
Not entirely. Some argued maybe internalizing it creates a separate consciousness, like a multiple personality that understands Chinese, even if Searle's main consciousness doesn't.
Whoa, okay.
Others talked about homunculi or different levels of description, but it often circled back to whether the whole system, internalized or not, possesses understanding, even if the conscious agent running it doesn't feel like he does. This kind of bleeds into the virtual mind reply.
Ah, the idea that the running program itself creates some kind of separate virtual mind that understands.
Precisely. Forget the man, forget the room or the hardware. Focus on the software, the running program. The argument is that this running process might instantiate a distinct mind, a virtual entity that possesses the understanding of Chinese.
Like characters in a complex simulation, they exist within the simulation's logic.
Kind of. Proponents suggest Searle is committing a fallacy by focusing only on the implementer's experience. The understanding could be an emergent property of the computational process itself, a mind distinct from Searle's.
But that sounds a bit ghostly. Where is this virtual mind?
That's the criticism.
Yeah.
It can seem metaphysically extravagant. How does this virtual mind relate to the physical world? Does it have beliefs and desires separate from Searle? It raises tricky questions.
Okay, so that's the something else understands camp. What about modifying the system? The robot reply seems key here.
Very much so. The robot reply concedes that, yeah, maybe a disembodied computer just shuffling symbols in a room won't get semantics, but they say, put that computer in a robot body.
Give it eyes and ears, hands and feet.
Exactly. Let it interact with the world. Let it see a chair, bump into it, learn to associate the word chair with the actual object. Through sensory input and interaction, ground the symbols in real-world experience.
That seems like a much stronger candidate for understanding. It connects the symbols to the world.
It does. This taps into ideas about embodied cognition and how meaning might arise from interaction. Supporters argue this robot could learn what hamburger means by, seeing them, maybe manipulating them robotically.
But Searle wasn't convinced.
Still skeptical. He argued that adding sensors and robotic limbs just provides more syntactic input to the person in the room or the computer. The robot's camera sends pixel data, the touch sensors send pressure readings. It's all just more symbols to be processed according to the rules. The person inside still doesn't connect the symbol hamburger to the experience or meaning of a hamburger. They just correlate it with other incoming symbols from the sensors according to the program.
So more inputs, same problem. Syntax without semantics. What about simulating the brain directly? The brain simulator reply.
This one argues, okay, forget generic programs. What if we build a program that perfectly simulates the exact pattern of neuron firings happen in the brain of a native Chinese speaker while they're understanding Chinese?
If it works exactly like a Chinese understanding brain, surely it must understand.
That's the intuition. Functionally, it's identical at the neural level. But Searle brings out another vivid counter scenario.
The water pipes.
The water pipes. Imagine the room is now filled with an incredibly complex network of pipes and valves, laid out exactly like the neurons in a Chinese brain. The program tells the person inside which valves to open and close in response to the input symbols. Searle says it's just intuitively absurd to think this plumbing system understands Chinese. Simulation, again, isn't duplication.
But what about that cyborgization idea?
Yeah.
Replacing neurons one by one with functionally identical artificial ones.
That's a powerful challenge to Searle's intuition. If you replace one neuron, do you lose understanding? Probably not. 10, 1,000, your whole brain.
Yeah.
If each artificial part perfectly mimics the function, where does the understanding disappear? Or does it?
It forces you to decide if it's the biological stuff or the functional pattern that matters.
Exactly. Searle's combination reply imagines a robot with this brain-simulating computer inside, behaving indistinguishably from a human. He admits we'd attribute understanding based on behavior until we found out it was just a simulation. Then, he claims, our attribution would be withdrawn.
Which leads us nicely into the third category, questioning the setup or the intuitions, like the other mind's reply.
Right. This one basically says, look, Searle, how do you know anyone else understands Chinese or anything? All you ever observe is their behavior.
We assume understanding based on actions and words.
Exactly. So if a computer can pass every behavioral test for understanding just as well as a human, on what grounds can we deny it understanding? Isn't that just chauvinism against silicon? It brings up the whole philosophical problem of other minds.
And Searle's response.
He insists the question isn't how we know others understand epistemology, but what it is we're attributing when we say they understand metaphysics.
Wow.
He thinks we're attributing genuine internal cognitive states with semantic content, not just the capacity to produce behavior. Acting like you understand isn't the same as understanding.
But if the behavior is truly indistinguishable,
Then critics say the internal state becomes irrelevant, or at least unknowable and perhaps unscientific to insist upon. It bumps up against behaviorist ideas and Turing's original concerns.
then there's the intuition reply, directly attacking that gut feeling that the man in the room doesn't understand.
Yeah, this reply says the whole force of Searle's argument rests on this intuition, and intuitions can be unreliable. Maybe our current concept of understanding is just folk psychology, and a scientific understanding might need revision.
Like how our intuition about solid objects breaks down at the quantum level.
Exactly. Maybe our intuition about understanding will change as AI develops. Some argue Searle is just analyzing the ordinary English word understand, not making a deep scientific point. Others point out the extreme slowness implied in the original Chinese room setup might bias our intuition. If it replied instantly, would we feel differently?
It questions the very foundation of the argument, our gut feeling.
Right. Is that intuition a reliable guide to the metaphysical reality of understanding, or just a reflection of our current conceptual scheme and technological limitations?
Okay, that covers the main replies. Now, fast forward from 1980. We've had decades of insane progress in AI. Has that changed the game?
It's certainly changed the context dramatically. We've seen Moore's law, massive computing power, sophisticated robotics, neural networks, and especially recently, large language models, LLMs.
Like ChatGPT and its cousins.
Exactly. These systems emerged around late 2022, and their abilities are frankly staggering. They generate fluent, coherent, often insightful text on almost any topic, drawing on vast data sets. They can write code, pass exams, hold conversations.
So, do they understand? Have they finally escaped the Chinese room?
That is the hot question right now. And there's no consensus. Some, like physicist Sabine Hossenfelder, argue they understand in a way analogous to how humans understand complex physics by building predictive models without necessarily having deep intuitive insight.
Others, like NVIDIA's CEO Jensen Huang, have claimed these LLMs have learned to understand language and common sense.
Right. But then you ask the LLMs themselves, and often they give quite nuanced answers, sometimes saying they process information and generate responses based on patterns, but don't understand or feel in the human sense.
Which is itself a pretty sophisticated response.
It is. It leads to this weird situation. If an AI becomes so good that its linguistic behavior is indistinguishable from a human's, and it even denies having real understanding in a way that seems contextually appropriate, does the question of whether it really understands deep down even matter anymore? Or does it become an undetectable, perhaps irrelevant internal state?
Has the simulation become effectively the same as the duplication, at least from the outside?
That's the philosophical conundrum these new technologies are forcing us to confront, making Searle's argument arguably more relevant than ever.
Let's pull back again to the big philosophical themes. Syntax versus semantics is clearly central.
Absolutely the core. Searle's mantra: programs are syntax, minds have semantics, and syntax alone isn't sufficient for semantics. The Chinese room is the intuition pump for that conclusion.
He even formalized it. Premise 1, programs are formal, syntactic. Premise 2, minds have mental contents, semantics. Premise 3, syntax is not sufficient for semantics. Conclusion, programs are not sufficient for minds.
That's the logical structure, and it challenges not just AI, but any theory claiming human cognition is just computation.
But people push back, saying computers aren't just syntax.
Right. They're physical systems. There are causal processes happening, electrons flowing, states changing. It's not just abstract rules. Maybe semantics arises from this underlying causal complexity, even if we describe it syntactically.
Like the recipe versus the cake analogy. The recipe is syntax, the baking process, and the resulting cake involve real physical causation.
Exactly. The program needs to run on hardware to cause anything.
What about Searle's later argument that syntax itself is observer relative? that you can see computation in a wall if you interpret it right.
That was another interesting move. He argued computation isn't an intrinsic feature of physics, but depends on interpretation. Since consciousness is intrinsic, it doesn't depend on being interpreted, you can't reduce consciousness to computation.
The critics jumped on that too.
Oh yeah, they argued there is a real difference. Computers are built to follow programs, to have specific causal powers linked to state transitions defined by the software. A wall isn't. Implementation involves harnessing specific causal powers. It's not just arbitrary interpretation.
So the debate shifts to whether meaning comes from internal relations or external connections.
Broadly, yes. Some theories, internalist or conceptual role semantics, suggest meaning arises from the relationships between symbols or states within the system itself. Others, externalist theories, argue meaning comes from the causal links between the system's states and the external world they represent.
And the robot reply fits more with the externalist view.
Definitely. It emphasizes grounding symbols in perception and action in the world. But Searle himself doesn't buy into these causal theories of semantics either. He keeps coming back to intrinsic intentionality.
Okay, let's talk more about intentionality, the aboutness.
Historically, it was seen as the mark of the mental. Searle's distinction is key here. Original intentionality, in minds inherently about things, versus derived intentionality, in symbols or computers about things only because we interpret them that way.
And computers only have the derived kind, according to him.
Yes. But critics question this sharp divide. Is intentionality really all or nothing? Couldn't complex causal connections to the world grant a system some degree of original intentionality?
Like Daniel Dennett's view.
Dennett argues all intentionality is derived, even ours. Attributing beliefs and desires, taking the intentional stance, is just a useful way to predict behavior, not about discovering some deep intrinsic property. He thinks Searle confuses having intentionality with being aware of having it.
So maybe Searle's original intentionality is just a specific kind of self-awareness.
That's one line of criticism. Others argue intentionality is an intrinsic feature of physical systems that reliably track information about the world, whether biological or not. The focus then shifts to how those connections are established, maybe through learning or evolution.
And Searle increasingly seemed to link intentionality and understanding to consciousness.
Yes, especially later on. The real missing ingredient in the Chinese room, for Searle, became phenomenal consciousness, the subjective feeling of understanding. If the system isn't conscious, it can't truly understand.
Which brings us back to the mind-body problem.
Indeed, the systems and virtual mind replies really poke at this. Is mind tied to a physical body? Is it an emergent property? Is it an abstract computation? Searle's view is biological naturalism. Consciousness is caused by brain processes and is itself a higher-level feature of the brain. He stresses the unique causal powers of biological brains.
But doesn't that sound a bit like substance chauvinism, only brains need apply?
That's the charge. Functionalism offers an alternative. Mental states are defined by their causal roles, not their physical substrate. So in principle, a silicon-based system could have mental states if it implemented the right functional organization.
And the Chinese room is a direct challenge to functionalism.
It is. It tries to show you can have the function, the program execution, without the mental state, an understanding. But functionalism itself faces challenges, like explaining subjective experience or qualia.
So many interconnected debates. Lastly, simulation versus duplication.
Searle insists simulating understanding isn't duplicating it. Simulating a fire doesn't burn anything.
Exactly. Some argue that for certain properties, especially functional or organizational ones, a robot that walks. Exactly. Some argue that for certain properties, especially functional or organizational ones, a perfect simulation is a replication. If understanding is a specific type of information processing, then simulating that process perfectly would be understanding.
And the evolutionary point seems strong, too. It's a puzzle for Searle. If a perfect simulation of understanding is behaviorally identical to the real thing, how could evolution select for the real thing? What survival advantage does genuine, intrinsic understanding offer if a simulation does the job just as well? It risks making real understanding seem like an epiphenomenon, something causally inert.
Like the joke, man says to his robot companion, "I know you're just simulating love, but it feels so real." Robot replies, "Thank you. My simulation finds your validation computationally rewarding."
Precisely. If the output is the same, distinguishing the real from the simulation becomes deeply problematic.
So, wrapping this all up, where does the Chinese room argument stand today? Is it settled?
Far from it. You'll find philosophers and cognitive scientists strongly defending it and others dismissing it entirely. There's absolutely no consensus on its soundness.
But the debate it ignited continues, especially as AI gets more sophisticated.
Absolutely. While AI researchers work on things like symbol grounding, connecting symbols to the real world, addressing the robot reply, and philosophers debate theories of content and consciousness, the Chinese realm remains a crucial reference point. It forces us to scrutinize claims about machine understanding.
We still see companies claiming their AI understands what you say or knows what you mean.
Exactly. And Searle's argument, like Leibniz's mill before it, serves as a persistent reminder. Just because a complex system processes inputs and produces impressive outputs, it doesn't automatically mean genuine meaning or mind is present. How semantics arises from syntax and how consciousness arises from physical processes remain profound mysteries.
So it seems we won't really resolve the Chinese room until we have a much better handle on meaning, mind, and brain.
That seems right. Which leaves a final thought for you, the listener. As AI continues its rapid advance, what would convince you that a machine genuinely understands? What would that proof look like? And if we did achieve that, what would it tell us about the nature of our own minds?